talk about Rescript more generally. So Rescript is a programming language that compiles to JavaScript, and it has a sound type system. What else would you say about it?
So Rescript it's a programming language that's focused, I would say it's focused on the web. It's focused on simplicity and speed. Like speed is a core feature. It's something we care deeply about, that we have a fast compiler, that we have a fast feedback loop in the editor, that we have a fast feedback loop wherever there's an interaction with the language itself. We care deeply about simplicity. The way I usually describe it is, if you want to contrast it to TypeScript, TypeScript wants to type the JavaScript you've already written, or the JavaScript that you write. You're writing JavaScript and it wants to type essentially everything in JavaScript, right? And it does it really well. So TypeScript is fantastic at what it does. It's an amazing type system, an amazing feat of engineering overall. It tries to type all of JavaScript, and all of JavaScript has grown over the years to be a pretty massive shed of tools. Can't really clean it up too much because you'd break a lot of the web, which is, you don't want to, right? You can evolve the language. TC39 is evolving the language, but evolution is slow, and still there's a massive amount of features. There's a massive amount of ways of doing things. So imagine there's a shed of many tools. Some of those tools are really sharp, are really good, really well thought through. A lot of those tools are not that sharp, doesn't fit that well together, or there's 4 or 5 different tools that do the same thing from different generations in a tool, like in a product line, and so on. Rescript's philosophy and idea is that if you open the Rescript tool shed, you'll try and where's all the stuff? You look around and try and find all of the tools. But the point is we want to have few tools, but that are really sharp and work very well together, essentially. So the philosophy is that with a few very sharp tools, you can get really far. And we want things to be simple, to stay simple data structures, simple types, not too much magic, essentially, because we believe that makes things more maintainable, more approachable, and all of those things. It's that philosophy, essentially.
Okay. So I was reading through the docs, and one of the differences with TypeScript that it lists is that, as you said, TypeScript tries to type the entire JavaScript API, which is crazy. There's lots of stuff that can happen. Just even the way they're able to know that code paths have certain values available and types have happened. Crazy stuff is happening there. But on the homepage, you guys say that you only do a subset of JavaScript. So in practice, what does that mean? What don't I have available to me? What programming constructs do I go to instead of other ones?
There's plenty of stuff you don't have available to you, so to speak. So one, classes is the main thing maybe in Rescript. You can get a development workflow that's very similar to the ergonomics of classes and methods and those things, but you don't have actual classes in the language. You don't have inheritance, those things. It's functional in that sense. We encourage you to write functions that operate on data and that you can chain together and those things. So that's one example. There's plenty of others. The JavaScript API is massive. We don't have generators, for instance, generator functions, although we're interested in getting them. But essentially, when we look at what things to bring into Rescript from JavaScript, we want them to work well with what we already have. So the core kind of features of the language, for instance, variants, records, pattern matching, those things, we want them to should work really well with them. It should also add something, because we view all of the adding something to the language is a huge cost, in that you're giving people another tool that they may or may not use, but it can create confusion around, should I use this for this or that for that, and so on. So we want it to be as simple as possible. So the bar for adding new stuff is high, but we also want to stay close to what JavaScript developers typically want to use. So one example is asynchronous programming. We could have probably come up with a bunch of other ways of doing this than the native JavaScript way. There's tons of prior art in both our kind of mother language, OCaml, but also in other languages for how to do asynchronous and concurrency and those things. But we opt to build async await into the language just like it works in JavaScript, just because it's familiar. It's something that's virtually everywhere in the JavaScript ecosystem. And it has some kind of it gets some interesting traits in Rescript that makes it more ergonomic, I would say, if I dare, than in JavaScript and TypeScript, so to speak, which are kind of interesting. It's a good example of when bringing something in and making it work well with the existing language yields a good kind of synergy effect, so to speak. So for async await, specifically, it's in Rescript, everything is an expression, which means that if you've ever done a React component and you're 2 layers of divs in and you want to write an if and you can't because you can't write expressions in the middle of JSX, you have to write a ternary or some other, make it a function, compute it before, or everyone has felt this. In Rescript, everything is an expression, so you can put an if or whatever you want, a block of code, wherever you want, essentially. Mm-hmm. And what's great about this, doesn't sound that much just from the get-go, but what's great about this is that it allows you to co-locate your logic where it's supposed to be. So if you're forced to break something out to a function when it's only really for this place, you're forced to do an immediately invoked function or a nested ternary of 5 levels or whatever. If you're forced to do those things, you're doing them because of a limitation in quotes of the programming language, not because that's what you want to do. And expressions everywhere is a very nice thing that lets you put code where it belongs. And for async await, in Rescript, the big thing is a switch, essentially. It lets you pattern match on anything. So it's like the switch in JavaScript, but on steroids is usually what we say. So you have a switch, and then you can switch on virtually any data structure, and the compiler will make sure that you handle all of the possible cases for this data structure. And you can also switch on an await. So you can switch await, and something happens, and then you can pattern match on that promise throwing or failing, rejecting, and on it succeeding. So you can get this nicely boxed in error handling that's very succinct. It's literally one extra line, and it compiles to the regular try catch, and then define your variable above in the scope and assign it, or use a var if you're that kind of person. And then you have your try catch and finally on those things. But it lets you integrate this right into the code where it matters, so to speak. So you don't have to do this ceremony of writing a try catch, even though that's not really what you were after, so to speak. So that's a good example of when a feature from JavaScript blends very well into the core features of the language. And that's the kind of things we try and find. So when we bring in new stuff, which there's a high bar, but of course we want people to be as productive as they can be with JavaScript through Rescript. So we want to bring in stuff from JavaScript as well, but there's a high bar. But when we do it, it's important that it works really well with the rest of the language.
Yeah, the switch await thing is really nice, because I think one of the problems I have with async await is like so many people just don't do error handling.
Yeah,
it's just like they only code for the happy path, because it's like annoying a little bit. And you see like a lot of libraries that come out, that there's one that I used for a long time that you essentially like wrap whatever you're going to await and await that thing, and then it'll return tuple, essentially like a array with like 2 items. One could be the success case and one could be the error case, and then that like messes up the like type inference and a bunch of other stuff. So it's like, I don't know, it's nice. And I would go further and say there's like so many niceties just because it's like a functional language. You had mentioned pattern matching earlier, like proper pattern matching, so good. I use TS pattern a lot in TypeScript projects. It's unfortunate that it's a runtime cost that you have to pay. And then proper like variant enums Rust has, it's like that's missing from TypeScript, JavaScript world. The pipe operator, which we've been talking about in JavaScript for a long time, but like can't collectively agree on like how we want it to work.
Like pattern matching is probably the thing that when people go into Rescript and then go back out of it, that they miss the most, just because it solves so many problems and quite elegantly as well. And it's, again, you can emulate this well in TypeScript, I would say. Like TS pattern, for instance, is very cool. There's a bunch of other pattern matching libraries, but it's runtime. It's not first class in the language. In Rescript, it compiles to really efficient JavaScript as well. It compiles to what you'd write by hand if you had to optimize it, which is a bunch of ifs, essentially. But you don't want to look at that. You want to look at the nice switch instead. But it's one little thing about switch await and those things. One other really good thing with having a sound type system is that you can do very much with statical analysis or static analysis around your program. So one example is we have a tool called reanalyze in Rescript that can go through your entire program and figure out exactly, for instance, say that you have a variant case or you have a record, it can figure out that this record field is never read. It's constructed, but you never read it, for instance. It can figure out that it's never read nor written to or created. And going back to async await and error handling, it can also actually figure out that here's a promise that could reject where you haven't handled the rejection, the possible rejection. So it can do that type of linting for you. And it's a whole program thing, and it's also very fast. So it's something I use all the time. And one of the things I perhaps miss one of the things I miss the most, I would say, when I do TypeScript stuff, because I still do a lot of TypeScript stuff, and being able to start reanalyze and have it analyze the code base and tell me what things are dead code. So like across the entire program, what things am I not using, and down to the field level. That is, for me, who do a lot of work in big code bases of various kinds, being able to reliably clean up old code is actually one of the biggest wins for me with a sound type system. Just because otherwise, you know how it is, like old experiments, things lie around, new person comes in, they browse the code base, they're supposed to find information about something. AI nowadays, also like the agent browses the code base, tries to figure out information, goes through a bunch of code that's really dead or old or in another convention or whatever that should be removed, essentially, outside of the obvious like gains of compilation speed and bundle size and all those things. So that's something I really, it's a benefit of the soundness that you can do that with the type system.